My name is Avi Zurlo. I'm our Chief Product Officer at NIL Foundation. Originally, this presentation was titled something like Horizontal Scalability for Ethereum. I changed it to Sharding is Dead, a little tongue-in-cheek. And as I was walking over today, I was thinking about, like, what do I want you all to take away from this presentation? And at first, I wanted you to believe that sharding is alive, okay? But I'm not going to go that far. I want you to come away from this conversation, or this presentation, believing that it could be alive, or that maybe we should resurrect it in some way. Okay, so let's get started. Okay, so this is a quick overview of what we're going to talk about today. We'll go through some scaling. We'll go through what happened with execution sharding relative to Ethereum. Talk about sharding versus rollups, and then how might we find some balance. Okay, so what are our options for scale? This is a very abstracted view on how we might try to solve for scale. And there's really two frameworks for scale of any database system, and this applies to blockchains. And there's vertical and horizontal. Now, Ethereum traditionally has skewed far to the right, going after horizontal scaling techniques. And the reason for doing so is that horizontal scale allows you to add new machines to the system and make use of that new capacity. In vertical scaling techniques, you increase the hardware power or capacity of a single node. And this obviously conflicts with Ethereum's sort of strongly held view of keeping at-home validator requirements quite low. Hi, Emmanuel. So in vertical scaling, you can introduce more powerful hardware. You can increase hardware utilization, things like the parallelized virtual machine. You can, and traditionally, the latter is considered a little bit more, harder on a relative basis than the former. And then in the horizontal world, you have modularity and sharding. Now, like I said, more powerful hardware. This is kind of like a no-no for Ethereum. Higher hardware utilization, which I mentioned is like parallelized virtual machine, but also like increasing the block limit, right? This is a form of vertical scale that makes like maybe a lot of sense, but that's people are figuring that out. Modularity, we've done this, good. Sharding, maybe not so much, right? In the early days, Ethereum really wanted to pursue sharding, and that was scoped down, and we were kind of left without it. So we're going to talk about sharding. Okay, but quickly, horizontal scale. I mentioned a few of the benefits on the previous slide. Got a little ahead of myself, but horizontal scalability has strictly higher theoretical limits for scale than vertical scaling, right? If you take them in isolation. Just imagine you have, a machine, the world's most powerful machine. Now, if I have two of those, and I can make use of 51% capacity of both of those machines, I now have more processing units, or more processing power. Right? So horizontal scale is much higher theoretical limits. It's future compatible with a lot of vertical scaling techniques, and it's also conducive towards decentralization, right? Because instead of having to max out a full node, we can actually just add new full nodes to the system and make use of them. And we've done modularity, distributing workloads by task. We haven't really done distributing workloads by state. Okay, and sharding and blockchain is just like super simple concept. And I kind of realized, over the last few months talking with folks, like maybe this is not intuitive, but it's like very simple. Like this is the most naive form that you could do it. Now, what are the interdependencies between states, and how are these states managed and operated, and what kind of consensus you run to actually agree on like state transitions, like all of that stuff. These are sort of nuanced details of sharding, but sharding in its basic form is this. Now, a little bit more in sharding. There's a lot of text here, so I'm going to go through this one quick. But as I said, more machines go burr. This is good. We want more machines. Traditionally, in blockchains, sort of to elaborate on the naive implementation of sharding, shards are linked back to a main chain, like the beacon chain, frequently. This was the original Ethereum scaling vision, and then we sort of scoped down to what I like to call dank sampling. I hope Dankrad's not in this room, with roll-up-centric scaling. And sharding, despite it being kind of the ugly duckling of the scaling landscape, and apologize to all my near brethren and everybody else who's working on sharding, but it has been the ugly duckling, especially in Ethereum. Roll-up-centric scaling, big, juicy, centralized sequencers. This has easily been the dominant way, the zeitgeist for scaling Ethereum. And there are challenges, right? There was the fisherman's dilemma, which we'll talk about a little bit more later. And sharding is a complex protocol. Like, there's no way around that. And we actually have some people that have been working on sharding for some time. Okay, so I want to talk quickly about Vitalik's recent blog post, which, how many has actually seen this blog post? He writes like execution sharding versus layer 2. Okay. All right, so a few people. Okay, so the gist of it was there were some conversations going on Twitter about, hey, Vitalik, like, what is the difference between sharding and rollups? Like, aren't these the same thing? And maybe some of you agree with that. And many people do. And Vitalik wrote an article kind of walking through why he believed that sharding, execution sharding and rollups are essentially the same thing, and that we have achieved the same outcomes that we wanted to achieve originally when Ethereum was putting forth execution sharding as a scaling solution. And at a very high level, the reasoning was we had zkSnarks for verification on some sort of beacon chain. We had the L1 beacon chain that was the DA layer, and later we'll have DAS. And we had this this really simple diagram of a many-to-one block relationship. And Vitalik was saying, this, like, hey, like, we're doing the same exact thing. Now, I would like to assert that this is actually not true. And it's true from the perspective of Ethereum. If you are an Ethereum block, imagine you're an Ethereum block, and you're looking at the data that is inbound into your block. Ethereum execution sharding and Ethereum roll-up-centric scaling look almost exactly the same. But if you step back and you look at how a user is viewing a block, right, the execution of a block, say it, through a layer 2, these are very, very different. And this is what I would like to quickly talk about, how they are different, and maybe why, just maybe, we think of sharding as a serious solution. Okay, so first, generation. How do you add a new subsystem to this system of interest, right? In both, like I mentioned, modularity and sharding are both forms of horizontal scalability. Modularity, in principle, if you look at one rollup, it's splitting those tasks, or splitting workload by task. Now, if you look at a collection of rollups, right, we actually have splitting of tasks, and we have splitting of state. And how we add new subsystems in a rollup is permissionless. Anybody can come in and use one of the many stacks for rollups and run their own sequencer and choose how they post data availability. They can choose the frequency that they post proofs. They can make all kinds of customizations. They can alter the VM, and they can be part of this rollup-centric world, this universe. In sharding, you can't, at least in the sharding that we're working on at NIL. And this is a really important trade-off, right? In sharding, the addition of new shards is permissioned by the protocol and or the social layer. Now, some of you may be like, well, that kind of sucks. But this is a trade-off, right? And on the flip side, we have interoperability. And in interoperability, when we have controlled permissioning over how new shards are added to the network, we're actually able to get native interoperability. We don't need to coordinate between shards or different teams to establish standards to communicate with one another. This happens natively within the protocol, and that messaging happens in protocol. Whereas on the other side, you have rollups that now need to coordinate amongst each other, agree on a shared communication layer, a shared consensus layer, and establish these standards to have this seamless interoperability. And this is where I would argue that sharding as a system is far greater in terms of scaling than rollups. Because I can simply add new shards to my system, and it is truly still the same system of interest. As in, where I add new rollups to my system, these are new, distinct, fragmented, isolated islands that are part of this sort of abstract idea of an ecosystem. Now, this is all on a balance, a seesaw of trade-offs, right? And our Lord and Savior in Ethereum, Sriram, recently shared on Twitter, the core trade-off is super simple from a human analogy. You cannot do stuff on a whim and also expect others to go along with it. And this is really what we have to contend in the Ethereum Layer 2 ecosystem today. Okay, so how might we find balance? Okay, so I kind of already went through some of these problems, so this might be a bit redundant. So what I'm going to do is, these are all coordination problems. We have moving tokens from one L2 to another, right, which is typically called liquidity fragmentation or state fragmentation. We have cross-chain smart contract wallet support, so consistency of updating keys across L2s, coordination problem. We have decentralized validation infrastructure, and these first three I just stole from Vitalik, so nothing new there. And then we also have these really perverse incentives for L2s to remain in isolation, right? To capture as much as they can within their own ecosystem, within their own sequencer, and that's just a function of how these businesses are built, right? And that sequencer fees are the main driver of revenue for these corporations. And then, which is that one, or maybe the decentralized validation infrastructure is not so much a coordination problem, but it would have looked weird if I put something else other than coordination on my slide of coordination. And then we have actual social coordination across ecosystems. And this one is a really, really, monstrous problem, right? You have thousands of actors who all have their own economic interests. And I know that we're all here today, and this is L2con, and everybody wants to move forward and agree on these standards. But it's not just about agreeing in a point of time today. It's actually agreeing in perpetuity and making sure that we have the infrastructure in place to do so. And this, I reckon, is going to be very, very difficult. And I don't think it should be underestimated. Otherwise, Ethereum at large may be at risk. That was a little extreme, but you get my point. Okay. So those were the problems of today in rollups. Let's look at the problems that people theorized in the past about execution sharding. There was single shard takeover, and this being a big risk because you essentially have this global validator set, and then you split it, and you assign it to shards. And now you have a strictly less than n, where n is your global validator set of validators who are running consensus over each shard. And if one of these shards is malicious, you have to do network-wide rollbacks. Now, we have this actually today in rollups with shared sequencers. You still have this problem. In sharding, there was a lot of work that had been done around random sampling and random shuffling, right? Where you can introduce probabilistic guarantees that actually increase your security per shard. State transition execution correctness, I think probably everybody here is very familiar with all the work that has been done for roll-up proofs. This has come a very long way. It was, previously the fisherman's dilemma was a big blocker for sharding. Now we actually have very hard correctness guarantees from zk. Fisherman was a function of optimistic proofs or fraud proofs. And then cross-shard communication. This was always thought of as something impossible to build a developer experience around. How could we have like these separate fragments or shards of state and have to call between one another, right? How do we build applications, right, from smart contracts, moving from this synchronous execution world to asynchronous? Well, guess what? Like, that's where we are. It's an inevitability. We have this world of rollups. We have, hundreds of them. And guess what? The communication between them is asynchronous by definition. You cannot get around this. So this is sort of like an inevitability that we have to work around. And now there are solutions to having these mega solvers or builders that are tracking cross-domain and submitting slots across multiple slots, or this universal, how do we get back universal synchronous composability that Justin Drake talks so much about. And yes, all three of these problems existed in the past, and they exist today, and I would argue that they exist in a worse form. So maybe, just maybe, we should consider sharding as a serious scaling solution. But what am I saying? I'm not saying we should consider Ethereum. Ethereum should not go through execution sharding. Ethereum is a Chad. Okay, Ethereum has done one of the most based things you could possibly imagine as like any organization who wants to do anything. They've outsourced all of the work to other people, and this is remarkable. And the your favorite high performance L1 is probably a bit upset that they have to do all kinds of work to make their system scale. And we should preserve this. This is amazing, right? This is what makes Ethereum great. So what should we do now with I laid out this presentation. Sharding is serious. Hopefully, maybe a few of you believe me to a certain, I think you do. And this is what we're doing at NIL. So NIL is an Ethereum L2. It's based on zkSharding. We recently just launched our DevNet. You can all clap. Yeah. And we're going to be rolling out more later this year. And you can scan our QR code here to join our Telegram. Follow us on Twitter. And thanks for listening.
I think we might have like a minute or two for questions if anyone does. If not, I'm sure Avi will be around and you can speak to him IRL. Yes, we have a question over there.
Hello. Thanks so much for the talk. It was very interesting. I have a question. Right at the end, I was very excited about NIL. It makes sense, I guess. You launched the rollup, but then it itself has the sharding. I'm curious. Are you going to have like SDKs for the kind of like native interoperability you talked about between the shards in in the NIL stack?
Yes. I mean. Yeah, and our DevNet is it's a simulated sharding environment, and what we're looking to solve, one of the big problems that I laid out, was the developer experience around cross-shard calls. So yeah, we have a bunch of work there. You can actually test the sort of current implementation of cross-shard calls. We call them messages. So that's all live, and yeah, you could totally use it. If you find me afterwards, we can get you access. Yeah.
Thank you.